Okay, so this is an investigation. So that means you really should be trying to do this on your own. And if you need some help, then referring to this. Okay, so are the following points solutions? That means if you draw the line, is this point going to be on that line? Okay, a point that's on a line is a solution for that equation. Hint. Do you see this hint? I'm going to even highlight it. Plug the values of x and y into the equation. So I'm going to plug it in. So remember that this is my x value, this is my y value. So I'm going to replace, I have y equals 3x minus 1. I'm going to replace the y with the 2. I'm going to replace the x with the 1. So 2 equals 3 minus 1, 2 equals 2. Is that true? It is true. So yes, this is a solution. Okay, we're going to do the same thing over here. We're going to replace the x and the y, remembering that that's x and that's y. So I'm going to replace y with 5 and x with 2. 5 equals 6 minus 1. 5 equals 5. So hooray, that works. So this also, because when you plug it into the equation, it comes out true. Okay, so graph the line. So I'm going to graph the line. So my slope is equal to 3 over 1. My y-intercept is 0, negative 1. So I plot 0, negative 1. Remember, when it's a positive slope, it goes this direction. So I go up 3, 1, 2, 3. I go over 1. I go up 3, 1, 2, 3. I go over 1. Now I realize you don't actually need these little whoop-de-woos right there, but it makes it easier to do. And then 1, 2, 3, and over 1. Okay, again, I don't actually need these, but I do need to make my line. Oh, that was pretty bad. Remember, lines have arrows on them. Then it says, do the points 1, 2, so I'm going to change the color, 1, 2, that point right there, and 2, 5, do they lie directly on the line that you graphed? Yes, they do. They are on that line. Choose a different point on the line. So I'm going to change my color. On that line by looking at the graph. So I'm going to look at it. So I'm going to pick this point right here. And that's the point negative 1, negative 4. Now, it says prove algebraically. So I'm going to plug it in. My y value is negative 4. My x value is negative 1. So negative 4 equals negative 3 minus 1. Negative 4 equals negative 4. That works. So yes, it is a solution. It lies on that line. Based on your answers from number 1, number 2, number 3, where on the coordinate plane do you think all solutions will be? Will it be on the line? Will it be above the line or below the line? It will be on the line. Okay? The answers will be on. The solutions will be on the line. List one more solution. The only one that we can see that's a solution that we didn't try out is 0, negative 1. Okay. Now, pick a different color. Oh, I'm going to pick brown. It says now graph y equals negative 2x plus 4. So my slope on this is negative 2 over 1, so that's a negative slope. And it's the point 0, 4. So I'm going to come up here to 0, 4. Again, it's a negative slope, boys and girls, so that means it's going to go downwards. So I'm going to go down 2, 1, 2 over 1. Down 2, oopsie daisy, I didn't mean for it to do that. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay, now just because I really don't need the whoop-de-woos, I didn't mean to do that. There we go. Didn't mean to do that. I will draw that back because there we go. And I draw a line. Oh, that was a horrible line. There we go. That's pretty good. Not great, but pretty good. List 2 solutions. That means 2 of them that lie on that line. So I'm going to use a red dot. Oh, I don't know. I'm going to pick right here, and I'm going to pick right here. Why did I pick those? I don't know. So 2, 0, and 3, -2. Do the lines y equals -2x plus 4 and y equals 3x minus 1 have any points in common? Do they run into each other? Do they have the same point? Yes, boys and girls, they do. Actually, I'm going to highlight it right here. Right there. They run into each other right there at the point 1, 2. So at the point 1, 2, they run into each other. Okay, so the next one says, is the point you listed on number 8, so the point 1, 2, a solution for both equations? Okay, so 1, 2, we already did that one up above here. 1, 2 was right here. So we already know it's a solution for that one. We need to know if it's a solution for the other one. I'm going to pick a different color. So we need to know if it's a solution for this one right here. So I'm going to replace the y with 2 and the x with 1. So 2 equals -2 plus 4. 2 equals 2. Yes, I explained it, or I looked at it graphically. I did it algebraically, and yes, it is. Summarize. How can you find a solution that satisfies 2 linear equations simultaneously? That was bad. By looking at their graphs. Okay, so it's where the 2 run into each other. So that's how you will know, is when the 2 graphs run into each other. So when the 2 graphs run into each other. Another way to say that is when they intersect. When they intersect. Okay, so if I'm looking at this, what's the solution? It's where they run into each other, right there at that point. So the point 1, 2. Where they run into each other? The point 0, -1. Now, we have to graph these next ones in order to find out where they run into each other. So if I look at the first one, this one right here, it has a slope of 1/2, has an y-intercept of -4. So I go down to -4, 1/2, up 1 over 2, 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 or from the y-intercept, down 1 to the left 2, 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 down 1 to the left 2. Okay, so now I draw a line that hopefully goes through all of them. There we go. And then I'm going to pick a different color because I like blue. The slope on this one is the number sitting in front of the x, boys and girls. The number sitting in front of x is a -1 and 0, 2. So I go to 0, 2, and my slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1. Now some of you are going to say, oh, I don't need to graph the rest of it because, yeah, I'm finished. If you leave it like this, you will get points taken off. This is not finished until you actually graph the line, boys and girls. You can't just put dots and not graph the line. And we put arrows on it. Where do they run into each other? At 4, -2. Okay, and then we have one last one. And I'll even change it to, I want to do orange. So my slope on this one is -2/3. My y-intercept is 0, 2. So I'm going to go to 0, 2. It's a negative slope, so it's going downhill, boys and girls. So I'm going to go down 2 to the right, 1, 2, 3. Down 2 and to the right 3. Down 2 to the right 3. Or from the y-intercept, I can go up 2 and to the left 3. Oops, it's not writing. There we go. 1, 2, yeah. Up 2 and to the left 3. Up 2 and to the left 3. And draw a line. There we go. Pick a different color. Oh, I don't know. This blue. Slope on this one is 2. The y-intercept on this is 0, -6. So the first thing I do is I plot the 0, -6. And then 2 is the same thing as 2 over 1. It's a positive slope. So I'm going to go up 2 over 1, 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 and the other direction, down 2 over 1, down 2 over 1. And I take this and I make a line. Okay, and where do they run into each other? At the point 3, 0. Okay.